Alright guys, we're going to wrap up chapter 1 with solving compound and absolute value inequalities. Okay, so our objectives today, we're going to be able to hopefully at the end of this lesson solve compound inequalities and then solve absolute value inequalities. So first let's get into compound inequalities. These consist of two inequalities joined by the word and or the word or. And in order to solve one of these, you must solve each part of the inequality. So what do I mean by that? Let's get right into it. So it says and compounds. This is a compound inequality containing the word and is true if and only if both inequalities are true. So for example here, they show you, so just to be clear, the compound inequality is this piece right here, but they're showing it to you in steps. So they're saying, okay, if x is greater than or equal to -4, this is what the graph looks like, right? And then if x is less than 3, this is what the graph looks like. If it is an and statement, right, if it's saying that x is greater than or equal to -4 and x is less than 3, then what it's saying is both of these things must be true on the graph, right? So if both of those are true, we only include the space in between those things. All right, notice that we include the -4 because it's or equal to, right? But at the 3, we have this open circle. All right, so that is the and compound. For example 1, it says solve and graph the solution on a number line. Okay, so here's where we get into a little bit of the algebra of this. Remember that in my definition I said to solve one of these you must solve each part of the inequality. So in order to do this, we always include this middle piece here with both inequalities. Okay, so what does that mean? That means I'm going to look at this section and solve that, and then I'm going to solve this section. So notice there's just the overlap of the center piece when we're solving these. All right, so let's do it. So let's take a look at, we can do this all at once. It's not bad to do it all at once, or you can separate them out and do two separate things. I like to do it all at once. So whatever we do to the middle, we must do like in order to get the middle, because the goal here, guys, is to get the middle to just be x, to isolate the variable. So whatever we do to get rid of the pieces that are in the middle other than x, we have to do to both sides of the inequality. All right, got to treat them almost as two separate problems. All right, so I'm going to just show you what that looks like. If I want to get this x by itself, I'm going to subtract 8 here, here, and here, all three places. Okay, if I do that, this goes away. All right, and I still have the 4 there. I haven't taken care of that. Okay, and then 32 minus 8 is, what is that? That's 24. And then -12 minus 8 more is -20. Okay, so then to get x by itself, I have to divide everything by 4. So I get -5 is less than or equal to x, which is less than or equal to 6. Okay, so what this means is, it means that the unknown value, is somewhere between -5 and 6, and it could include -5 and 6, right? This is or equal to. So when I go to graph this, put -5 here, we'll put 6 over here. We have solid circles, okay, and we're going to include all values in between -5 and 6. So and statements are in between graphs, okay, saying that both things are happening. So let's look at another one of these. This is now 1b, where we have -5 is greater than or equal to 3z minus 2, which is greater than -14. All right, so for this one, same type of deal. I'm going to add 2 everywhere. That gets rid of this. Okay, -2 plus 3 is -3, which is greater than or equal to 3z, which is greater than -14 plus 2 is -12. Then I'm going to divide everything by 3 to get that z by itself. So I have -1, which is greater than or equal to z, which is greater than -4. Okay, So notice for this one, it's saying -1 is greater than z. So let's take a look at this. -1 is greater than z, and z is greater than -4. Okay, so it's somewhere between -4 and -1. So notice, since these things are a different direction than less than, we just got to be careful there. So if this is 0, this is -1, this is -2, this is -3, this is -4, we're just saying that z lies between -4 and -1. Okay, so if I'm going to go to graph this, notice at -4 we have an open circle because we don't include the -4, but we do include the -1 somewhere in here. Okay, and if you want to test this, you guys, it's very simple. All you have to do is take one of the values that we graphed and see if it makes sense. If you put a -2 in there, right, is -1 greater than or equal to -2? And you should say yes because it's further right on the number line. Okay, and is -2 greater than greater than -4? And yes, it is, because it is further right on the number line. Okay, so -2 does work. It is part of my graph, and I'm good to go. Or compounds, on the other hand, happen when we have to use the word or, and it's a compound inequality containing the word or, and is true if one or more of the inequalities is true. So it's just saying, hey, the solution could be this, or it could be this. All right, so we're going to graph those, and they often go in opposite directions. All right, so for example 2, we're going to try to solve these guys. So we're going to solve these independently, okay? And then we're going to graph them on the number line. So to get j by itself here, I'm going to divide both sides by 5. And when I do that, I get j is greater than or equal to 3. Or I'm going to divide both sides by -3. Remember, when I divide by a negative, I have to flip my inequality. Okay, so j would be less than or equal to -7. So it's saying this could be true or this could be true. So I have to graph both possibilities. Okay, so if 0 is here, it's always good to mark 0 with a lot of these. -1, -2, -3, -4, -5, -6, -7. Okay, so it's saying at -7, 1, 2, 3, 4, 5, 6, 7. At -7, we have a filled in dot. It's saying j is less than or equal to that. So we're going to go this way. And then at 3, it says j is greater than or equal to 3. Okay, so I like to label my graphs at least where these are happening. So filled in circle there, going off in that direction. Okay, so if I choose a number on the number line, if I chose a number like -2, for instance, it should not work in either one. Okay, so if I plugged -2 in for j here, notice -2 is not greater than or equal to 3, does not work, right? -2 is also not less than or equal to -7 on this particular one, so that does not work. So that's a good sign because I don't have -2 graphed, right? The only thing on my graph is what's shaded on either side. All right, so for 2b, let's try this one out. So let's add 6 to both sides on this. Okay, when I do that, I get g is greater than -5. And then over here, we're going to subtract 4 from both sides. And when I do that, I get 2g is less than -19, I believe. And then g will be then less than negative, 9.5. Okay, so that's for 2b. And then when I go to graph this, notice this is saying g values are greater than -5. Okay, so if we go to, let's put 0 here, -1, -2, -3, -4, -5. -5 is here. Okay, it's greater than, g values are greater than -5. Okay, so that's everything greater than -5. That's to the right. And then g values are also less than -9.5. So 6, 7, 8, 9, 10, somewhere in the 9.5 range. I'll put it right here. Okay, somewhere in between. So this is -10. I like to just label these a little bit so I can see what's going on. and we'll go that way. Okay, so that's example 2. Then, absolute value inequalities. Okay, guys, this is where you really got to pay attention. Okay, so absolute value is the difference from 0. That is very important. It is the difference from 0 on a number line. Okay, distance. I don't know why I said difference. I guess difference makes sense, but really it should say distance, I believe. It's the distance from 0 on a number line. Use this definition when you're dealing with inequalities. You can say the words, the difference of x from 0 is. Okay, so, and then whatever it is. I'll show you an example of that here in a second. So example 3, we have the absolute value of t is less than 6. Okay, so what this is saying is, remember that whenever you have an absolute value, it is a distance, right? This is a distance. So we can say the difference from t to 0, so I'm actually going to write this out because I think this is actually that important. The difference from t to 0 on the number line is, in this case, less than 6. Okay, so if we don't even worry about math, right, and we just think about that, here's 0. If the difference of the variable that we're talking about, so like the number that we're talking about, if the difference from the value to 0 on the number line is less than 6, then what we're saying is we can go 6 in either direction, right? All of these values up to 6, a distance of 6 in either direction. This direction 6, this direction 6. Everything works as long as we are less than 6. Like the distance from 0 is less than 6. So notice, you guys, just if that's still not clear, 5.9 is less than 6 away from 0, right? On the number line, it's somewhere in here. Okay, but notice that also negative 5.9 is also less than 6, right? It's just in the other direction. So we have 6 units this way, 6 units this way, and we have to account for everything in between because remember that an absolute value is talking about a distance from 0, so it could go in either direction. Okay, so looking at B is interesting because it says the distance, so like if you think about this as a distance, we can say the difference from u to 0 on the number line is less than a negative number. Okay, so can you have a distance that is less than a negative number? And the answer to that is no, you cannot. You cannot have a negative distance. So this is never the case. So we just say that is no solution, and we just keep rolling. Okay, so whenever we have a distance that's less than a negative, it is no solution. But we got to be careful, because what if it said, and we'll see one of these here in a second, but what if it said the absolute value of u was greater than negative 3? Okay, so let me ask you a question. When is any distance greater than a negative number? And your answer to that should be always, right? And any distance is gonna be greater than negative. Okay, because there is no such thing as a negative distance. So that will always be the case. So you really got to pay attention to these inequalities. Here for 3c, it says the absolute value of t is greater than 3. What that's saying is the difference of t from 0, t from 0 on a number line is bigger than 3. Bigger than 3. Okay, so here's 0. 1, 2, 3, 1, 2, 3. In either direction, it does not matter. Direction does not matter, right? Okay, so this is just talking about distance. The distance is bigger than 3, so it doesn't include 3, right? So if we want to look at the values that are bigger than 3 from 0, we're going to be going this way. So this is going to be an OR statement. All right, so notice, if our variable's on the left, whenever we have a greater than sign here, and I guess I shouldn't put a line under, I'll put an arrow. Whenever we have a greater than sign, it's going to be an OR. right? It's going to be or. But whenever we have a less than sign, it'll be an and. Okay, when the distance is less than some value. Let's look at 3D. So this one says the distance u from 0 on a number line is greater than -2. So again, when is a distance greater than a negative number? Always. So this will be all reals. And if they want you to graph that on a number line, it's pretty simple. All you do is, we'll use a different color here, you just show that everything is shaded with arrows in both directions. Okay, the whole number line is shaded. Moving right along to example 4, it says to solve